Lesson P.3. This will be on page 21 in your textbooks. The one standard we are going to discuss in this lesson: solve linear equations and inequalities in one variable, including equations with coefficients represented by letters. To start this lesson, we are going to review some properties of equality. The first one, addition property of equality. If we're adding the same value to both sides of the equation still holds true. Same thing for subtraction, multiplication, and division. Okay, the top four, those are ones we've used since 8th grade when solving basic linear equations. As long as we do the same thing to both sides of the equation, we're okay. Then we have the reflexive property, which you will remember from geometry. Anything is going to be equal to itself. Symmetric property, if A equals B, then B equals A. The transitive property we also talked about quite a bit in geometry. If A equals B and B equals C, then A must be equal to C. And then the last one, the substitution property. If A is equal to B, then B can replace A in any expression, and vice versa. A could replace B in any expression. In this first example, we want to solve this linear equation. We have 2 times the quantity 2x minus 3 plus 3 times the quantity of x plus 1 equal to 5x plus 2. So the first thing we're going to have to do is distribute 2 to both terms inside the parentheses. 2 times 2x is 4x. 2 times negative 3 minus 6. Same thing, we have to distribute the 3 to both terms inside the parenthesis. So we have 3 times x, positive 3x, 3 times 1 plus 3 equal to 5x plus 2. On the left side of the equation, we have like terms that we can combine together. 4x and 3x will give us 7x. Negative 6 plus 3, we have minus 3 equal to 5x plus 2. Now we need to get like terms on the same side of the equation. So I can subtract 5x over, which leaves us with 2x minus 3 equal to 2. Add 3. 2x equal to 5. And then the last step, divide by 2. So we get x equals 5 halves. So a review of things we talked about in previous algebra classes. First, we have to distribute. Then we have to combine like terms, use properties of equality to isolate the variable by itself. In this next problem, again, we want to solve this linear equation. We have 5y minus 2 divided by 8 equals 2 plus y over 4. There's a few different ways we could approach this problem. One method would be to get a single fraction on the right side of this equation, so we could get a common denominator and write that as one fraction. The reason we would do that is then we would have a ratio equal to a ratio, which is a proportion. Another geometry concept. To solve a proportion, we can cross multiply. All right, so that's one method we could use. Another method we can use is find the least common denominator of every term. In this case, we have a denominator of 8, 1, and 4. So the least common denominator is going to be 8. So we multiply the left side and the right side of this equation by 8. As long as I'm doing the same operation to both sides of the equation, we're alright. 8 divided by 8 cancels out. We're left with 5y minus 2 equal to, now if I distribute, 2 times 8 is 16. 8 divided by 4 is 2. 2 times y. We're left with 16 plus 2y. Now we have to get the variable isolated on one side of the equation, the constants on the other. So I can add 2 to both sides of the equation. Leaves us with 5y equal to 18 plus 2y. And then subtract 2y to the other side. Leaving us with 3y equal to 18. The last step, divide by 3. So we get an answer of y equals 6. So again, you could have written a proportion and solved by cross multiplying, or we can go through by finding the least common denominator. The nice thing about finding or using the least common denominator is that many things will cancel out, leaving you with a fairly nice linear equation that you can solve. Now we're going to move on from equations and move to inequalities. There are 4 types of inequalities. We have less than or equal to, greater than or equal to. There are 3 properties for inequalities we are going to discuss. The transitive property, very similar to what we talked about earlier. If u is less than v and v is less than w, then u must be less than w. The addition property, if u is less than v, then u plus w is less than v plus w. As long as we're adding the same value to both sides of the equation, that's going to hold true. Also, if u is less than v and w is less than z, then u plus w is going to be less than v plus z. If we're adding the 2 smaller values together, they will be less than the 2 larger values added together. The third property, multiplication, if u is less than v and c is greater than 0, then u times c is less than v times c. As long as we're multiplying by the same value and it's positive, that inequality is going to hold true. If u is less than v and c is less than 0, it's a negative value, then u times c is going to be greater than v times c. Think back in your previous math classes when we worked with solving inequalities. Whenever you multiply or divide by a negative, the inequality sign is going to flip. At the bottom, that simply tells us that these properties will hold true if we replace less than with less than or equal to, and there are similar properties for greater than and greater than or equal to. Now we're going to go through our first example of solving a linear inequality. We have 3 times the quantity x minus 1 plus 2 less than or equal to 5x plus 6. First thing, we need to get rid of these parentheses by distributing. Gives us 3x minus 3 plus 2 less than or equal to 5x plus 6. Combining like terms on the left side of the equation, we have 3x. Negative 3 plus 2 is negative 1, less than or equal to 5x plus 6. Need to get like terms on the same side, so we can subtract 3x to the other side of the inequality, leaving us with negative 1, less than or equal to 2x plus 6. And now we subtract 6 to the other side. Negative 7 is less than or equal to 2x. And now the last step, divide by 2. So we get an answer of x is greater than or equal to negative 7/2. If we go back and look at this step where we had 3x minus 1 less than or equal to 5x plus 6, just like any type of equation or inequality, there's many different ways you could solve this. There's not necessarily one right step. So you could have subtracted 5x to the other side of the equation. The reason I didn't do that is because the variable x would have a negative coefficient. So later on in the problem, we would have to divide by a negative, which means we would have to worry about flipping the inequality sign. That's why when I'm solving inequalities, I try to make the coefficient in front of my variable positive. If I do that, then I never have to worry about multiplying or dividing by a negative and having to flip the inequality sign. In this next example of solving linear inequalities, we have fractions involved. We have x divided by 3 plus 1/2 greater than x divided by 4 plus 1/3. We know in order to combine fractions, we have to have a common denominator. And even if we don't want to combine these fractions, we can use a method we discussed earlier. We can multiply this whole inequality by the least common denominator. So if we look at our denominators 3, 2, 4, the least common multiple of those is going to be 12, which means that's our least common denominator. So if I multiply the left side of the inequality by 12 and the right side of the inequality by 12, each of these terms is going to simplify down nicely. 12 divided by 3 is 4, so I have 4x plus 12 divided by 2 is 6, greater than 12 divided by 4 is going to be 3 times x, and then 12 divided by 3 is going to be plus 4. So now I just have a linear inequality with no fractions. Just need to get like terms on the same side of the inequality. So minus 3x. Again, I'm subtracting 3x to the other side so that I keep the coefficient in front of my variable positive. So now I have x plus 6 greater than 4. Now subtract 6 to the other side. Final answer is x is greater than negative 2. So any value of x greater than negative 2 will satisfy this inequality. The last inequality we're going to solve is a doozy. Okay, we have multiple inequality signs going on, but it's actually a lot simpler than it looks right away. All we have to do is the same operation on all three parts of this inequality. This is called a double inequality. So if we're trying to isolate x by itself, the first thing we need to do is multiply by 3. So if I multiply by 3 here, I have to multiply by 3 on the right, and I need to multiply by 3 on the left. So 3 times negative 3, I have negative 9. My middle simplified out. I'm left with 2x plus 5 less than or equal to 5 times 3 is 15. The next step to get x by itself is subtract 5. So I have to subtract it from the right and subtract that from the left. Negative 9 minus 5 is negative 14, less than 2x, less than or equal to 10. Now the last step, divide by 2. So we're left with negative 7 is less than x, which is less than or equal to 5. So this is our answer in inequality notation. We could also write this in interval notation. And I'm going to show you interval notation because that is a more standard or common notation when we're involved with higher level mathematics. Inequality notation is what we first learned. It's easier, but interval notation is more condensed and it's used more in calculus for those of you that plan to take that. So the least value I can be is negative 7. So I write my negative 7. The value is not equal to, meaning it's open. If it's open, we have a parenthesis. And then I have a comma. The maximum value I can be is 5. That value is equal to, meaning it's closed. So we have to use a bracket. Thus, we go from our inequality notation to interval notation. This is a more condensed, easier to work with notation, has the same meaning for our solutions. The last thing we're going to discuss in this lesson is isolating a variable. So we're going to solve for the variable r in this case. We have volume is equal to pi r squared times h. This is the formula for the volume of a cylinder. Okay, a right cylinder. So if I want to isolate and solve for r, I need to move the pi and the height to the other side. These are being multiplied, so I can move them at the same time. I can divide by pi times h and divide by pi times h. So now we're left with volume divided by pi h equal to r squared. Now to get r isolated by itself, we would have to take the square root of both sides of this equation. If we do that, we know the square root and the squared simplify with each other. So we're left with r is equal to the square root of v divided by pi times h. Technically, we would have plus or minus over here, but since we're talking about distances and measurements, volume, we can't have any negative values. We're only going to include that positive value. This lesson involved a bunch of review from previous algebra stuff, just like everything else we've been talking about so far. So we wanted to make sure we could solve linear equations and inequalities in one variable, and then including equations with coefficients represented by letters.